So for the next series of simulations, we will try to see what is the influence of relaxation on the transverse and longitudinal magnetization. In order to perform this simulation, let's keep the mode of relaxation as normal in the simulator, and the T1 and T2 rates are set to 10 seconds each so that we can clearly see what is going on. And we shall turn off the B1 and torque just so that we only visualize the magnitude of transverse magnetization. We can also turn on the MX magnetization so that we actually see precision as well. B0 is set to 6 units and the frame of reference is the rotating frame. I request you to pay attention to two things in this simulation: to look at the magnitude of the transverse magnetization and also the magnitude of the longitudinal magnetization followed by the perturbation. I shall be applying a 90-degree hard pulse. The moment we do it, we'll be tipping the magnetization from B0 axis to the transverse plane. And once having done that, let's see how the magnetization, especially the transverse magnetization mod of MXY and MX, changes as a function of time. And let's apply a 90-degree hard pulse. You're able to see the length of the vector reduces as a function of time. This is exactly what you're seeing as mod XY reducing over a period of time, small t, given by the time constant T2. Of course, in this simulation we have set T2 to 10. We will see other simulations where we keep T1 and T2 different from one another. Maximum limit of T2 is equal to T1, which is what we have set in the simulation. And you are also able to see slowly the equilibrium magnetization returns back to wherever it was. Let's return back to equilibrium. And then we can set a simulation where T2 is less than T1. I'm keeping T1 as 10 seconds and T2 as 5 seconds. So let's apply a 90-degree hard pulse. Having applied, you are able to see that the transverse magnetization is decaying and simultaneously longitudinal magnetization is coming back. But even before the entire equilibrium is established, so we were here when the transverse magnetization almost went to zero, the longitudinal magnetization is still recovering. So this is what is the influence when T1 is greater than T2, where it takes a longer time for magnetization to return to its equilibrium along Z than for the transverse magnetization to decay. We will know the significance of this as we go forward in this course. I request the students to please repeat some of the simulations so that you also understand how precession works and how relaxation ends up influencing the magnetization along the transverse and longitudinal axis following a perturbation, which is our RF pulse. In the next lecture, we will be looking at a formalism in order to put all of this in mathematical equation.